Hare Krishna everyone. So welcome to the lecture series of quantum mechanics. So in today I'm going to start with Compton effect. So let's get started with Compton effect. Compton effect. Okay. So let us consider let us consider let us consider a photon a photon of energy h nu naught and momentum P initial is equal to your h nu naught upon c colliding colliding elastically 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 with an electron at rest. Okay, so let me draw the case for you how the photon is elastically colliding with your free electron. Okay, let me draw that for you. Okay, so here is my free electron. This is my free electron, and in this direction, in x direction, I have my photon like this. This is my photon, and having your energy h nu naught and initial momentum pi. Okay, so after collision, what happens? The scattered electron will go in this direction, this is my x direction. Okay, this is my x direction, and what happens to the photon? The scattered photon will go along this direction, and the angle between your scattered photon and the angle between your scattered photon and your x-axis will be theta, and let this one is phi. Okay, here is your scattered electron. Okay, and this one is my y-axis. Understood? This is the case where we have scattered photon and scattered electron. Okay, so what happens? We know that in every elastic collision there is conservation of momentum and conservation of energy. So first we consider conservation of momentum. That means initial momentum is equal to your final momentum. So what happened in conservation of momentum? So we will see along x-axis we have initial momentum as your p initial is equal to your final momentum, that is pf cos theta. Pf is the final momentum of your scattered photon, and it is making theta with x-axis. That's why the x component is your cos theta. So, and electron momentum, that is pe cos phi. Okay, make it equation 1. And along y-axis I have the initial momentum is 0 along y-axis, and the final momentum is minus pf sin theta, and the final momentum is pe sin phi. Okay, you see there is the negative y-axis, that's why the negative sign comes. So from equation 1 we can write it as your pe cos phi is equal to your phi initial minus pf cos theta, isn't it? Yes. Make it a equation number 3, and I can write the equation number 2 as your pe sin phi is equal to your phi f sin theta, isn't it? Make it equation 4. Okay, so let's squaring and adding equation 3 and 4 we get what we will get? pe square cos square phi plus sin square phi is equal to your phi initial minus p wave cos theta square plus pf square sine square theta. Okay. So further calculation, you can get P square as cos square phi plus sin square phi is equal to 1, and opening the square we get P initial square Pf square taking common cos square theta plus sin square theta minus 2 Pi Pf cos theta. Okay, what it will give you? Phi e square is equal to your phi e I square Pf square minus 2 Pi Pf cos theta. Okay, make it equation number 5. Okay. So further we have your conservation of energy, that is your relativistic energy, relativistic effect. Okay, that is the conservation of energy. Conservation of energy. Okay, in conservation of energy we have h nu naught plus mec square MOC square, because we have taken the mass of photon as your MO. Okay, m naught c square is equal to your h nu plus m naught square c4 plus p square c square the root over. Okay, where this term comes, this is the relativistic effect, and this one is the energy of your electron, and this one is your final momentum of final energy of your photon. Okay, so further calculating we can get h nu naught minus h nu plus m naught c square, okay, whole square is equal to your m naught square c4 p square c square. Okay, here p is the momentum of electron, pe square, it's better to write that. So it will become your h nu naught minus h nu square plus m naught square c4 is equal to your m naught square c4 plus pe square c square. Okay, cancelling m naught square c4 on both sides, we can get h square nu square minus plus h square nu square minus 2h square nu naught, okay, is equal to your pe square c square. In place of pe square you can write from equation number 5, that is your, so writing from equation number 5, substitute the value of pe, so you can get pi square c square plus pf square c square minus 2 pi pf c square cos theta is equal to your h nu h square nu square. Okay, let me write it for you. H square nu square minus h square nu naught square minus 2h square nu naught. Okay, fine. So further calculating you can get your so yes, yes, so let's substitute in place of pi. You can substitute, you know that your momentum is equal to how much is h nu naught upon c, and phi f is equal to your h nu upon c. So substitute these values, so you can get from here by substituting and cancelling on both sides the terms h square nu square, you can get your 2h square nu naught 1 minus cos theta is equal to your 2 m naught c square h nu naught minus h nu. Okay, so for the solving you can get the values as your 2h nu naught 1 minus cos theta is equal to your 2 m naught c square nu naught minus nu. So cancelling 2 on both sides, and 2 on both sides, you can get your h upon m naught c square is equal m naught c square into multiplied by your 1 minus cos theta is equal to your nu naught minus nu upon nu naught. Okay, h upon m naught c 1 minus cos theta is equal to your c into 1 by nu minus 1 by nu naught. So for the calculation you can get h upon m naught c 1 minus cos theta is equal to your lambda, as your c upon nu is lambda, lambda minus lambda naught. So the wavelength shift that is del lambda is equal to lambda minus lambda naught is equal to your h m naught c 1 minus cos theta. So this is the final Compton shift expression of your Compton effect. Okay. So let me write some of the important points about your Compton effect. I can also write this equation as your 2h m naught c by substituting 1 minus cos theta as your sine square theta by 2. I can write it as sine square theta by 2. Okay. I can write it in this way also. Let me take equation number 6 and further proceed. Okay, so proceeding further, I have some of the important points related to your Compton effect. You should know these points about your Compton effect. Okay, so Compton effect provides direct confirmation of particle nature of light, particle nature of radiation or light. Okay, and the scattered wavelength of photon depends on your angle of scattering and wavelength of incident beam. Okay, scattered wavelength depends upon two factors, that is your angle of scattering and wavelength of incident beam. Okay, thirdly, I have the diagrams, the graphs between your, that is lambda and I with respect to your lambda. Okay, it will be like this. Okay, this one is your lambda s or lambda simply you can say, and this is your lambda naught. This one is graph, you should remember this. And secondly, I have the graph between your lambda shift, that is your wavelength shift, and between the scattering angle. Okay, so this one will be like this. Oh sorry, it's my mistake. It will be like this. Okay, if I will have to cut like this. Okay, this will be your 2 lambda e and this is be your lambda e, and this one is del lambda, and it will cut your x-axis, that is theta axis, as this. The maximum value you can get with the value of theta as your 180 degree, and the minimum value you can get with the value of theta as your 90 degree and 270 degree. This is your 270 degree. Okay, so lambda e, I can write it as h upon m naught c, that is the value 2.43 into 10 to the power minus 12 meter. That is the Compton wavelength. Okay, you can also write it as 0.0243 Armstrong. It's very important, remember this value. Next we have your energy, that is Es. I can write it as E naught upon your 1 plus E naught upon mc square, m naught c square into 1 minus cos theta. Okay, in number 5 we have Compton shift. Compton shift means the wavelength shift, that is del lambda can't observed for bound electron. Okay, bound system electron experimentally, because it is only valid for your free electrons experimentally, but valid theoretically. But theoretically we can say that is bound electron, okay, but experimentally it can't be observed. So at number 6 we have loosely bound electron from outermost cell is required for your Compton shift. Compton experiment is required. In number 7 we have Compton effect is best exhibited. Compton effect best exhibited with short wavelength radiation, short wavelength, or we can say that long frequency, okay, radiation, high frequency radiation like x-ray. At number 8 we have, remember the Compton wavelength. When you are writing Compton wavelength, you should write the maximum value of it, that is h upon mc, okay, and use E square is equal to P square C square M naught square C4 for calculation of momentum, okay. At number 10 we have Compton effect can be observed in visible region. Compton effect, sometimes our questions comes from this section. Compton effect can't be observed in visible region, okay. At number 11 we have maximum Compton shift, as I have talked about in the curve between your lambda and your theta, that is maximum Compton shift, that is your del lambda max will be equal to your 2h upon mc, and in place of theta we have 180 degree, so it will becomes maximum value, and its value at minimum would be your cos theta. For cos theta will be your 0 degree, that's why del lambda minimum will be your 0, okay. At number 12 we have Compton wavelength of photon. If I have to write Compton wavelength of photon, what I would write, that is your lambda v is equal to your h upon mpc upon calculation, putting the values, that is 6.6 and 10 to the power minus 34 upon your mass of photon and your that is c wavelength, so you will get 1.32 into 10 to the power minus 15 meter. As I can say, this is your photon, okay, you will have to do it. And at number 13 we have Compton wave, we have uncertainty principle. Uncertainty principle can be easily understandable with the help of Compton's effect. So this is all about your Compton effect, okay. It's an important long question for your BSc, okay, and it's in view of your entrance examination problems comes from these portions, okay. So thank you for watching this video. So do like, share and subscribe my channel. This will give me motivations. Your one like will give me motivation to do my content more clarity, okay. So thank you for watching. So,